This is Chemistry 1. There you go. All right, so what were we doing before Christmas? What we did is we said this chapter is about how to write formulas. Everybody got that? So writing formulas, no one taught this to me. No one taught me type 1, type 2. They just said, do this, do this, do this. And I never saw a pattern. But there's a pattern to it, okay? If you can understand type 1, you can see how type 1 is exactly like it. Type 2 is like it, except one little change. You change one little thing, that's it. And if you understand that, I say type 3, you'll say, well, that's like type 1 and 2, except you just have to do this. Is everybody with me? Okay, do me a favor, and I can't see May. So if you can, there you go. All right. I want to be able to see over, okay? All right, I'm going to start all over again, but I'm going a little faster. You ready? You have your packet with you? Let's try it. If you're going to name compounds, the easiest ones are called type 1. Now, I'll never ask you what type they are, but your brain will say, oh, that's a type 1. And here's what you do. If you want to belong to this club, you have to be what? You have to be, what's binary mean? Excellent. Excellent. So I'm going to write one, okay? Watch. NaCl. That only has one element. It only has 2 elements. You're right. Binary. 2. If you're a type 1, you have to be ionic. What does that mean? What is it?
Metal and non-metal.
Yes. Okay, so let's go again. You look at the table. And periodic table right here. Let's put hydrogen right over here. Now, excuse me. That's the dividing line. All these are metals. Metal, 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 metal. Get them? And then here's your little tiny non-metals right here. Even though they're non-metals, they don't like to form formulas, so they don't like to form compounds, so we won't be talking about them. Get it? So how many non-metals are there? Not too many. Not too many. See? So if you have a metal and a non-metal together, you're going to form an ionic compound. Look. Metal. Non-metal. Ding, ding, ding. Am I binary? Yes. Are you ionic? Yes. Okay. Do you contain an always metal? Which ones are the always metals? Now, even though we did this about 6 or 7 times before Christmas break, let's do it again. Which ones are the always metals? That means in a compound, they will always have the same charge. Which ones are always? Group 1A. See that 1A? These are always plus 1. Always. Plus 1. You get it? What are these in a compound? Group 2A are always going to be what? Yes. Plus 2. And you're 2 for 2. And then there's 3 others. Here they are. Silver, zinc, aluminum. What's silver, zinc, aluminum? Plus 1, plus 2, plus 3. Get it? Now, if you are, if the compound is binary, if it is a metal and a non-metal, and it contains an always metal, then we're ready to go. We're ready to go. And here's what you do. How do you name it? You say the name of the metal. Now, instead of saying the name of the non-metal, we do change the name because all binaries end in what? So we don't say sodium chlorine. What do we say? Remember that? Remember that? And we did this before Christmas break too. I said, this is fluorine, but if it was in a compound, it would be called fluoride. I keep going. Ready? Chlorine. All right. Bromine. Iodine. Iodide. Oxygen. Oxide. Sulfur. Sulfide. Selenium. That's a hard one. Selenide. That's weird. This one, nitrogen. Nitride. Phosphorus. Phosphide. Here's a hard one. Hydrogen. Somebody said it. Not hydroxide, but hydride. Hydride. You get it? Hydride. Okay. You're doing well. You're doing well. Okay. You can do more than 3 also. All right. Now, so let me write another one, okay? Let me write another one for you. BaCl2. Now, do you notice, is this binary or not? Does it only have two elements? All right, what do you think? Is it metal, non-metal? Your neck should get sore today. Is it metal and a non-metal? So you got to get quick at this. Now, is it one of the always metals? It is. So now, how do I write it? How do I say the name of it? Barium. And what are you going to say? Chloride. And that didn't matter, did it? That little 2? It doesn't matter. I will tell you when you need to look at that little subscript. You get it? I don't look at the subscript to name these. that's how easy it is to name these. Yes or no? Okay, now there's 2 things you have to do. If I write the formula, you have to come up with a name. But what if I give you the name and you have to come up with a formula? That's a little bit harder, but not a lot. It's not a lot. Let's try it. How about, what if I made a compound between calcium and fluorine? What would the formula be? So what if I said, how do you write the formula for calcium fluoride? You say, well, I'll bet it has calcium in it, and I'll bet it has fluorine in it. So how do I write the formula? Now be careful. Let's go over here. You told me that in a compound, calcium is always what charge? Not +1, but what? +2. So take your pen and go +2 there. Now, what I didn't talk about, I did it before break, but not after the break. What about the nonmetals? In a compound, these are going to be -1, -2, -3. Can you see that? Everybody got that? All right, so fluorine's going to be -1. But all compounds have to have a net charge of 0. Where am I at? Yeah. All compounds have to have a net charge of 0. +2 and -1, does that add up to 0? So we spent a lot of time before break trying to figure this out. That's not going to work. So what do I need? Do I need more fluorines or I need more calciums? And we even spent time drawing pictures. What if I had 2 fluorines? That would be -2, wouldn't it? What's -2 and +2? That works. So calcium, you see, 1 calcium and what? 2 fluorines. Yes? I'm not going to go to type 2 unless you understand type 1. I'm going to give you a hard one, okay? Aluminum oxide. I want you to see if you can figure out what would the formula be for aluminum oxide. I don't really care if you make a mistake. We just got back, didn't we? We just got back. Maybe you're going to make a mistake. That's all right. I will be impressed, though, with you being gone more than 2 weeks. If you come back and get this right now, I'll be impressed. You already done? Don't give the answer yet, okay? Hang on. Everybody finished? Uh-oh. Okay, just a little bit longer. Daniel, I don't want you to give me the answer. I want you to tell me how you got the answer.
So aluminum is +3.
How'd you know that?
Because it's on the chart. +3.
+1, +2. It's always metal, isn't it? So it's always +3. Go ahead.
And then oxygen is -2.
How do you know that?
Because it's in
Not -1, but
-2.
-2. But Daniel, that's not going to work because it doesn't add up to 0.
So you need 2 aluminums and 3
Right. Whenever you have this odd and even thing, the smallest number they both go into is 6, isn't it? So 2 times 3 is 6, and 3 times that is 6. So you get +6 -6. So Al2O3. What do you think? How many people got that right the first time? Ooh, okay. So what held up when you got started? Okay, Layla, what happened? Did you forget the aluminum was an always metal?
No, I just added another one to the oxygen.
Okay, So if you had this, if you had Al plus 3 and had oxygen minus 2, if you had another oxygen, that'd be 2 times minus 2, that'd be minus 4, wouldn't it? And see, minus 4 and plus 3, that's so, to get out of that trap, when you see a plus 3 and a minus 2, 2 times 3 is 6, and you put a 2 there and a 3 there, and that'll get you out of that trap right there. What do you think? Again, if you understand type 1 really, really well, then type 2 is exactly like it, except you do one thing different. You get it? Are you ready to move on or not? Because we spent a lot of time on this. You have to go back and remind yourself of what happened. All right, let's go to type 2. Type 2 is what? Binary. I know what that is. Type 2 is what? Oh, it's just like type 1, isn't it? And except what? What's the only thing different? Not an always metal. Okay, so let me write one for you, okay? FeO. There's one. But I happen to know that they're like that. I didn't do this. God did this. There's only one way to make barium chloride. That's why this is called an always metal. So he had some elements that said you're always going to be plus 1 or plus 2. You get it? Always. But guess what he did with iron? He said, you're not going to be one of the always metals. There's sometimes you're going to be plus 2, and sometimes you're going to be plus 3. I didn't do that, did I? But type 2 is exactly like type 1, except I have to spend just a little bit more time with it. So let's take a look at this. Ready? What would you call this? Let's see. What would you call this if it was a type 1? If it was a type 1, what would you call it?
You would call it iron oxide.
Right. So I'm gonna leave a little space here, but I'm gonna call it iron oxide. And what would you call this one?
Iron oxide.
That's right. So chemists are real people, aren't they? Don't you think they notice that there's something wrong here? We have 2 different chemicals, and they have the same name. We got to fix that. That's all they did. We got to fix it. What was the easiest way to fix it? Here's what they did. Ready? Find the charge on the metal and make that a Roman numeral. That's all they said. Now here's where it takes a little bit extra effort on your part, okay? Now watch what I'm going to do here. What's oxygen in a compound? What's the charge on oxygen in a compound? Not -1, but what? Okay, so let's do that. Let's put a -2 here. Let's go ahead and put a -2 here. Yeah. Now, all compounds have a net charge of what? If you're a real compound, you add up all the pluses and minuses, you get 0, don't you? Now, guess what? If this is -2, what does iron have to be to equal 0? Are you guys with me on this? Is that +2? Now, so I said that to fix this dilemma, all I need to do is find the charge on the metal. And what is the charge on the metal? It was 2, wasn't it? So I put Roman numeral 2. And this is like type 1, except I have to add a Roman numeral, don't I? I never add a Roman numeral to type 1. There's only one kind of sodium chloride. Let's try this one. This is a little bit harder. Ready? Each oxygen is -2, and how many oxygens do you have? Each oxygen is -2, and how many oxygens do you have? 3. What's 3 times -2? -6. Well, this better be +6 over here, or else we don't have a compound, do we? 2 times what equals +6? +3. Ah, so what is the charge on each metal? What's the charge on the iron? 2 times +3, right? So what's the charge on the iron? 3. So what I do? I put Roman numeral 3. What do you think about that? Okay, let's reverse it. Let me give you the name and see if you can come up with a formula. Want to try that? Let's try it. Copper 1 oxide. All right. see if you can write the formula for that. And again, I know you guys forgot a certain amount. I don't think you forgot it. It's just that it's not coming back quickly. You get that? Now, can I tell you a little trick on this? Instead of looking at the periodic table like I would for an always metal, I'm going to show you something. You see this says copper 1? You're going to tell me that copper's 1? I'll take it. You're giving me a hint. You said it was copper 1, so what am I going to write? Copper plus 1. Get it? And then what's the other element? Oxygen. Now my neck is going to get a little sore because I got to look at oxygen. What's oxygen in that compound? Not -1, but -2. Okay, now, is that going to work? No. What do I need? How am I going to make it add up to 0? Delaney, what is it? Yes, a total of 2, right? 2 times +1 plus, oh yeah, that's it. How do you write the formula for copper 1 oxide? Cu2O. Try another one. Copper 2 oxide. All right, try that one. Copper 2 oxide. You're pretty fast. You think you got it? Yeah, you got to teach me how to do this one.
So oxygen is always -2, and copper is +2. So
Is it always +2, or in this case?
in this case, it's 2 because of this.
And you know what? I think we're done. They add up to 0, don't they? I think we're done. All right, what do you think? So you gotta look at me because I have to know. Your face tells me a little bit of what's going on. You can fool me. You can't fool me, right? But I have to know if I see something like this, then I need to know, hey, let's ask a question, okay? You've done a good job answering questions. You're doing a good job. How many of you have not done your 3 questions yet? Hey, come on. You can do it. All right. You want me to give you a hard one? I think if you can do a hard one, how about I'll give you 2. I'll give you 2 hard ones. If you get both of them right, you're really good. You're really good, okay? Okay, so here I give you the name, you come up with a formula. Here I give you the formula, you come up with the name, okay? Can you see that? Yeah.
Wait, what was lead again? I kind of forgot.
Which one?
Lead?
Lead, okay, lead. Remember a plumber used to use lead pipes, so PB is the Latin word for lead, is plumbum. That's where we got the word plumber, because they used to use lead pipes. Then they figured out that's not good to have water run through lead pipes because a little bit of lead comes out, and lead's not good for the human mind. Pressure yourself a little bit and said, my goal is to get both of these right. Even if I make a mistake, I'll know what my mistake is. All right, how we doing? You guys have already answered a lot of questions, so I'm going to ask somebody else when they're ready. Anybody who hasn't fulfilled their quota yet, if you would like to tell me how to do either one of these, I'll do that. Maybe you want to do the first one or the second one?
Is the first one lead sulfide?
Right, you have to tell me the formula. It's lead 4 sulfide.
All right, let's see. Lead is, what's the thing in periodic for lead?
Huh? You want the symbol for lead? Okay, do you remember the story I just told? But PB, lead, plumber.
Oh, right.
Okay.
That's right, you did just say that.
Okay.
PB. Yes.
Okay.
Then we're gonna go with
What's-
sulfide, so that's S.
Yes. We're getting there.
And 6 or 4,
For what?
both.
Why both?
Because they have to be
I'm
compound.
going to agree with you that it said lead 4, and the Roman numeral is always a charge on the metal, so I'm going to give you that one. But what's the charge on sulfur?
-4.
How'd you know that?
It's canceled out.
Are you guessing?
Kind of.
Okay, I like that. Hey, thanks for being truthful. Ready? If it's a non-metal, these are always -1, but this column is what?
Okay, so it's gonna be -1.
Wait.
Wait. Oh, -2.
Okay, there we go. All right. So now we have a problem because that doesn't add up to 0, does it? What are you going to do? Do you need more sulfurs or more?
Let's see, we're gonna need 2 sulfurs.
Yes. And 2 times -2 is -4. That's going to do it. PbS2, you got it right.
All
All right. Now, Layla, you're going to do the next one. And Mg is magnesium, but what's Mn? Mg is magnesium, but what's Mn? Manganese. Here we go. Manganese. Manganese. And it's binary. All binaries end in IDE. What is it? Well, that's an F. What's the element? What's F stand for? What's what? Yes. Okay. Now, the only problem is you would be correct if manganese was an always metal. Look right here. This guy is an always metal. His called magnesium, but manganese is not. So now you have to do extra work. If it's not an always metal, you got to figure out the charge on the metal. I'm ready. Tell me how to do it. What's the charge on fluorine in a compound? F. What is it? Yes. Okay, so each fluorine's -1, but you have 3 fluorines. That means -3. But all compounds have to have a net charge of 0. So what's the charge on your manganese? 3. Yes. So what are you going to do about it? Yes. Are you with me? Again, if you understand type 1 and type 2 really, really well, I can teach you a lot. But you can't, if I start doing type 3, you can't go back and say, oh, I forgot which ones are always metals were. You got to know that. All right, I'm going to stop that for a minute, and we're going to go to type 3, okay? Now, I had assigned something for you, and I said if you did it on at home on Thursday night, then you really didn't have any homework over the vacation. Now, I'll give you a little bit of a break, You can give it to me tomorrow, and I'll count it full credit, okay? But what is it you were supposed to do as your homework before you left? Flashcards. Okay, so, hang on just a minute. Hello? Yes? Oh, okay. Oh, you can give it to me, and I can go send it to her. Is that? Would you be willing to bring it down here or not? Oh, okay, thank you. Bye. Okay, hang on. Here's what you do now, and I spelled this out. I'll even show you if I can find the one you had from. Here it is. Okay. Now here's what I asked you to do. You were supposed to make color-coded flashcards. Now what you do is And if you have them today, I'll go ahead and I'll grade it for you and give you a grade, and then that you'll be done with that, okay? And what I said was, this right here, this is a group of things that are called polyatomic ions. Now, at the beginning, I'll give you the sheet, and you won't have to memorize these, but eventually you're going to have to memorize a lot of these. Yes?
I don't have to this, but
That's fine. You don't have to. Now, but I'll tell you how to do it, okay? So let's say you have plain old pieces of paper. And by the way, you know what? You want to make them look nice because they're not for me. They're for you. If they look nice, you might actually use them. You're not making them for me. You're making them for you. So let's say you have some regular cards. I'll pull one out here. Here's one right here. And what I'm going to do on one side is notice that these are -1, -2, -3, +1. There are 4 different charges, so pick 4 colors that you like. If you have colored pencils at home, if you have something like this, I have 4 colors, okay? Now, I notice there's a whole bunch of -1, so I like red. So I think all my red cards are going to be the -1 guys. So what I do on one side, I write NO3 -1. Get that? And it's in red, isn't it? See? Now I've color-coded my card. There it is. It's color-coded. It's red. Because your mind actually does better at memorizing things when they see color. And what am I going to put on the back side? Nitrate. See? Eventually, you're going to have to tell yourself, when I see that, I say nitrate. I'm going to say nitrate. Get it? So what you do is, and I think there's about 25 of these, something like that. I think I crossed off a couple of them for you, didn't I? I think I did. Well, anyway, so what I'd like you to do is bring those tomorrow, and I'm gonna go ahead, and I know you haven't memorized any of these yet. That's okay. I know you haven't memorized them yet. So let's go ahead with type 3, and let's see what happens here. Okay. Now, type 3 is not binary. So here's the good news for you. I have a lot of good news for you here. Let's say I write NaNO3. Now that's a real compound. It's a real chemical, okay? I have some in the storage room right here. The first thing I notice is that you're not binary. Look, you have 1 element, 2 elements, 3 elements. You're not binary. You can't be type 1 or type 2, can you? So I got some good news for you. If you have more than 2 elements in you, good news number 1, it contains a polyatomic ion. Now, where is that pager? All right, so guess what? Okay, thank you. So good news number 1, if it has more than 2 elements, it contains a polyatomic ion. That's actually good news. Good news number 1, someone else has already named it. Good news. You don't have to worry about naming it. It's nitrate, isn't it? Good news number 2, you will never change the name of a polyatomic ion. Okay, I don't have to worry about doing the chlorine chloride thing, do I? It's always going to be nitrate. And see that? Does that make sense? Now watch what happens here. Do you see this right here? This is sodium. Is it an always metal or not? Is sodium an always metal? Then I don't have to worry about Roman numerals, do I? I don't have to worry about a charge. If you're an always metal, what am I going to say the name of that is? Sodium. And what are you going to say here? What are you going to say here? Nitrate? What? That's it? That's it? Yeah, that's it. That's it. Now, I know it sounds really, really simple. And I'm going to show you another one here. Let's do another one, okay? Barium. Let's do barium nitrate. Okay, now, be careful. And I know you guys are a little bit tired, but stay with me, okay? Stay with me about 5 more minutes. Now, I know it has barium in it, and I know it has this thing called nitrate. It didn't end in IDE, did it? So I know it's got this polyatomic ion in it called nitrate. So I'm going to write that down. But nitrate, and you're going to see my hand do this a lot. See this right here? It's got N and 3 O's in it, but think of it as one thing. Think of nitrate as my fist. How many nitrates do you see here? Please don't say 3. 1. 1 nitrate, you get it? And I look over here, and it tells me nitrate has what charge? What's the charge on nitrate? What does it say? -1. Nitrate, not oxygen, this whole thing here has a -1 charge. What's the charge on barium? Look up here.
2.
Isn't barium, what is it +2? Now, what are you going to do about this? Before, you would tell me, I said, do you need more bariums or more nitrates? What do you know? You need more bariums or more nitrates? To add up to 0, what do you need more of? Nitrates, right? Now, this is going to seem unusual to you. It's the only time a parentheses is used in a chemical formula. You told me I need 2 nitrates. I cannot write a 2 like that. That's not 2 nitrates. So how do I make 2 nitrates? Watch. Boom. See how I put in parentheses? See how I put the nitrate in parentheses? And I said, how many nitrates do you want? I want 2 of them. But each nitrate's -1. That's right. Give me 2 of them. And that'll be -2. -2 plus 2. I did it. I wrote the formula for barium nitrate. All right. Let me give you a hard one. If you can get the hard one, if you can get this right, I'll be very impressed. Okay? I will be very impressed if you can get this right. Wow, this would be really impressive. Now, do you know why I use the Roman numeral, don't you? Because he's not an always metal, is he? All right. If you can get the formula for this, I'll be really impressed. Now, you can use this, all right? You haven't memorized these yet, have you? So you want to look at your polyatomic ion sheet. Iron 3 carbonate. I think some of you should enjoy this because it really does take thinking. It's actually a thinking thing. We're not just learning words. We have some vocabulary words, but it's a lot about thinking and putting things together. And again, this is a pretty hard one, so I'm okay if you miss it. All right, raise your hand if you're done. Okay, all right, now, if you're done and the person next to you is done, show them your answer and see if they match. Iron 3 carbonate. And if they don't match, talk a little bit. If they don't match, talk a little bit. Did you guys match? Okay. Now, so did you guys talk about who maybe had it right? Huh? Okay. Did you guys match? Did you guys match? Now, if you didn't match, what kind of conversations did you have?
She showed me,
But how do you know she's right?
because I just know.
Okay.
I forgot to look at the chart.
All right.
She did.
Okay, excellent. All right, so here we go. Ready? Iron 3. Thank you for giving me that hint, that Roman numeral. Thank you for telling me the iron was +3. Thanks. I'll take it. And I had carbonate. You haven't memorized these, have you? I'll let you use this. All right, carbonate. Oh, there you are. Well, carbonate's what? CO3 with a -2 charge. I didn't do that. Somebody else already named it carbonate. That's -2. I can't change that. Well, what are you going to do about something that's plus 3 over here and minus 2 over here, huh? What are you going to do there? Remember we did that before? Remember a long time ago when we did aluminum oxide? Remember aluminum is plus 3 and oxygen is minus 2, and you said, what time 6 is the smallest number, 2 times 3? Remember that? We're going to do the same thing, aren't we? So what do you need? How many ions do you need? Plus 3, minus 2. How many ions are you going to need? What's the smallest number? And 3 and 2 both go into evenly? 6. What times 3 is 6? 2. I need 2 of those ions, don't I? 2 times plus 3 is plus 6. But now, how many carbonates do I need? How many?
3.
But how do I write 3 carbonates? How do I write 3 carbonates? Is that right? See? Raise your hand if you got that right. That's a hard one. That was hard. You got it? You give me that. I like that look. Thanks for doing that. What's that mean?
Why is the 2 negative on the CO?
Why is the what? Oh, carbonate? Okay, so carbonate is CO3, and the whole thing is minus 2 charge. You get it? So this whole thing called carbonate is minus 2, and this is plus 3. So I needed 2 irons, but I needed 3 carbonates. What's 3 times minus 2? Minus 6. What's 2 times plus 3? Plus 6. Okay, now, I want to challenge you, okay? I want to challenge you a little bit. If you'll go home today, if you'll go home tonight and just do some of these. Just do some of those. Now, some of them you can't do. Some we haven't done yet. But if you said, hey, I recognize that. And actually, I can see you starting here. Let me show you something. I can see you starting on, you can start on this page if you want. Shoot. Why don't you start here? Why don't you try these? Why don't you try these and see how that goes? And you have your polyatomic ion chart with you, don't you? Okay, now, so if you didn't do your flashcards yet, if you already did your flashcards, if you bring them up to me now, go ahead and give you a grade for it. But if you didn't do them, then do them tonight and then turn them in tomorrow.